champ, welcome into the another amazing session champ, and in this class we are going to learn how to prove that any number is irrational. So champ, in this class we will learn that how to prove any number is irrational. We will see the sum of irrational and rational and also the sum of irrational numbers also. So let's start champ. So let's say first of all that what are the irrational numbers? I have few examples over here, right? But are these all the examples are rational number? No, right? This number under root 4 is not the rational number. Why so? Because the number 4 is the perfect square. And whereas these three numbers are irrational. Why? Because the number inside the under root was not perfect square. That is why these are irrational numbers. I hope it is clear, very basic, right champ? Excellent. So now champ, how we can prove that these numbers are irrational, and that method is known as the method of contradiction. Let me explain it. Champ, let's see how to prove the irrationality of any irrational number. So let's say I have to prove that under root 2 is a irrational number. So what we will do? First we will assume that under root 2 is a rational number, right? Now champ, try to recall the definition of rational number. If any number is rational number, that number can be written in the form of P upon Q. So I can write under root of 2 equal to P upon Q. The most important condition, the P and Q are the co-prime integers and Q cannot be 0. Right champ? Now what to do? Simply do the square. After doing the square both sides, we will get what? 2 equal to P square upon Q square. Right champ? Now after this what to do champ? Simple. After rearranging this equation, we will get what? Q square equal to P square upon 2, which can be written as Q square equal to P into P by 2. Now champ, I know that this Q square is integer. If Q square is integer, so we can say that P square is divisible by 2, right? So now champ, if P square is divisible by 2, so we know one theorem that if P square is divisible by 2, so we can say that P is also divisible by 2. That means number 2 is the factor of P, right? Excellent. So now champ, if 2 is the factor of P, we can write P equal to 2m, where m is any whole number, right, other than 0, right champ? Now simply we can put P equal to 2m in the above equation, right? And we will get what? Q square equal to 2m square. Again the same concept, champ. Here we can write, after rearranging this equation, m square is equal to Q square by 2. Again the same method, right? That m square equal to Q into Q by 2. And from here we can say that Q square is divisible by 2 because m is the integer. If Q square is divisible, so Q must be divisible by 2 also. Now champ, this number P is divisible by 2. Number Q is also divisible by 2. That means what? That means champ, that this means that we had taken assumption that this is a rational number. And we took the assumption also that P and Q are co-prime integers. But what did we get? That both having the common factor 2. This is the method of contradiction, and with the help of this we can say that under root 2 is a irrational number. I hope it is clear. Excellent champ, very good. So now let's move on to the sum of rational and irrational is irrational. How to prove it? So let's say champ, the combination of these two numbers, okay? So let's say I have to prove that under root 2 plus 3 is irrational. How to do it? Just keep one concept in your mind, that in these kind of question, again we have to assume it is a rational number, right? Again we will assume the same thing. But here champ, what we will do, that after assuming the rational number, our main motive will be to keep irrational quantity on one side and all the rational quantity on another side. See over here, under root 2 equal to p by q minus 3. And why did we do it? To keep irrational quantity on one side and all the rational quantity on one side, right? So after taking LCM, it will become p minus 3q upon q, which is nothing but numerator is my integer. Why? Because p and q are integer. So this can be written as r upon q, where r is the integer, q is the integer. So champ, this r upon q is the rational quantity, right? And whereas this under root of 2 is irrational quantity. And how is this possible? Irrational equal to rational. It is never possible, right? So champ, we can say that it's a irrational and it's the rational. They can never be equal. So this is the contradiction, right champ? Excellent, very good. So with the help of this, we can say that whatever assumption we have taken, that is wrong. So this is the irrational number. Okay, champ, clear? Very good, excellent. Okay, so same guys, same champ, what we have done, just like the previous example, we have taken an assumption and with the method of contradiction, we have proved that it's an irrational value. I hope this is clear, champ. Very good, excellent. Now let's see the sum of irrational, the sum of two irrational is irrational. How to prove it? Again, the same concept. Okay. So now let's see the summation of two irrational numbers. Okay. So champ, let's say I have to prove that under root of 2 plus under root 3 is irrational quantity. Again, we will assume it's a rational quantity. So we can write in the form of p upon q. Again, our motive is what? To keep irrational quantity on one side and irrational on other side. So in this one, under root 2, under root 3, both are irrational. So what we will do? We will square both the side, champ. We will take the square both the side and it will become what? Very simple. A plus b to the whole square. A square plus b square plus 2ab equal to p upon q to the whole square. So this will become 5 plus 2 root 6 equal to p square upon q square. Again, champ, see the final expression. Under root 6 equal to this quantity. Irrational equal to rational. Like I told you, our main motive is what? To keep irrational value on one side and all the rational value on the another side. Now very simple again, the same funda, right? So we can say that under root 6 equal to this rational quantity, right champ? The irrational equal to rational. It is possible. What do you think, right? So champ, we have a contradiction again over here, which is our assumption is wrong. We can say that under root 2 plus under root 3 is the irrational quantity. I hope it is clear. Very good, excellent. Okay, champ, now let's summarize our class. Okay, now let me tell you that whatever we have learned and a very important concept also. So in this class, we have learned to prove the irrationality of number such as root 2, root 3, root 5, etc. We use the method of contradiction. So what we do in this method? First, we assume the number is to be a rational value. Then equal to p upon q, where p and q are co-prime, and in the last we prove that p and q are not co-prime, right? Same here. Then we get a contradiction, and with the help of contradiction we can say that whatever we have assumed, that is wrong. So we have assumed that number is rational, but after the contradiction, number is irrational, right champ? And after that we have seen the combination of rational and irrational. How to do it? Very simple. Just keep rational value on one side, irrational value on another side. In all of these kind of example, just keep one thing in your mind. Keep irrational quantity on one side, irrational on one side, right? And which is not possible. Hence, with the method of contradiction, we can say the number is irrational. I hope it is clear. Very good. Okay, champs, so that's it for this awesome class. I hope you enjoy the class. Be curious and be safe.